Hello, so we are going to solve a wonderful problem now. Let's read out the problem first. Find the area of a rectangular plot of ground which has a perimeter of 42 meters and a diagonal length of 15 meters. All right, so we have a rectangular plot which is provided here. So let's name them first. That's going to be y and x. Let's name this as a, b, c and d, and I'm gonna have a diagonal which is of length 15 meters. Okay, and we are supposed to calculate the area of this plot of rectangle. Okay, an additional problem to this, I would probably define it now, is let's also try and calculate this this area here. All right, so let me call that as a, and let's calculate the area of the rectangle in addition to the area of the triangle a, b, c, and triangle and area of the triangle, let's say DAE, and area of the triangle AEB. Okay, let's try to find these out. So I'm gonna need a lot of space, so I'm gonna use the space available pretty judiciously. All right, let's write down the solution first. Now we all know that from Pythagoras theorem, the length of the diagonal here, which is AC, I can always write it as AC squared, is AB squared plus BC, AB squared plus BC squared. Okay, in terms of x and y's and the natural values, this translates to 15 squared is going to be equals to AB is x squared plus y squared. That means that it is x squared plus y squared is equals to 225. So we got our first equation, and the second equation also states that the sum of the perimeters, or the total perimeter of this, is equals to 42 meters. That means 2x plus 2y is given to be equals to 42. Because everything is divisible by 2, I take the liberty to divide by 2, and I'm going to get x plus y equals to 21. Let's re-express this in terms of y. So y, making the subject as y, so y is going to be 21 minus x. So I'm going to put this as equation 2. What I'm going to do now, I put this equation into equation number 1. So what is then going to happen is pretty much simple. So that is going to be x squared plus, in the place of y, I'm going to get 21 minus x whole squared is then going to be equals to 225. So this is then going to transform into x squared plus 441 minus 42x plus x squared is equals to 225. 441 minus 225, let's find out how much is that. 441 minus 225, okay, 260. So I'm going to get 2x squared minus 42x plus 216 is equals to 0. Everything's divisible by 0, so we can take the liberty to divide by 2. So everything's divisible by 2, not by 0, so we can take the liberty to divide by 2. I'm then going to have x squared minus 21x and plus 108 is equals to 0. All right, it's pretty simple to see that these two have factors already. So 21, you can break them up as in terms of addition to be equals to minus 12 and minus 9, and this to be equals to minus 9 and minus 12, or rather minus 12 and minus 9, which is a product now. So I'm then going to have two factors easily now. X squared minus 12x minus 9x plus 108 is equals to 0, which is taking these two as taking x as the common factors here. And then going to be x minus x times x minus 12 minus 9 times x minus 12. Okay, so that is then going to be equal. These two are the common factors. Let's take them out. So I'm then going to be left with x minus 12 times x minus 9 is equals to 0. So these two give us factors which are equals to x is equals to 12 and x is equals to 9. Let's put them into equation 1, both of them. In equation number 1, when I substitute x equals to 12, I'm then going to get a y value of 9. Say for example, when x becomes 12, y is going to become 9, and when x becomes 29, y is going to be 12. All right, so y is going to be 12. So you notice what is happening. So when x is 12 and y is 9, in other words, when x becomes 9 instead of y, then y becomes 12 instead of x being 12. All right, so that means, what is the problem or the solution telling us? The solution tells us that you're then either going to have a standing or a sleeping rectangle, or a vertical rectangle. Okay, or a vertical rectangle, right? So the sleeping rectangle in the form of 12 and 9, this is going to be in the form of 9 and 12. Okay, in other case, it is just a rotation of one of the triangles, one of the rectangles. All right, so it doesn't really matter which one you consider for the case right now. But looking at the given problem looks like the horizontal edge is longer, so I'm going to select this. That means I'm going to select the case where x is equals to 12 and y is equals to 9. Okay, now selecting that x is equals to 12 and y is equals to 9, let's proceed forward. Now the area of the rectangle, entire rectangle is just xy, that is 12 times 9, which is 108 meter squared. So we have already found out the answer to the first part of the problem. Second part of the problem is that we got to find out area of the triangle ABC. Now the area of the triangle ABC is pretty simple, half times base times height. So area of the triangle ABC is pretty simple, half times base, which is AB, times the height, which is BC, which is then going to be half times base is x times y. So that is half times 12 times 9, 2 times 1, 2 times 6, 6 times 9 is 54 meters square. So let's try and find out the area of this guy over there. Area of this, in order to find the area of this triangle, we got to know what is this length, isn't it? We got to know this length. Let's find out what is that length. This length is pretty simple to find out. If you observe closely, this length here, from here to here, is the half of the total height, right? So the total height for us is y is equals to 9, or in other words, this height is going to be 4.5 meters, or 9 divided by 2. All right, so we have a wonderful problem here where this edge here is going to be then all right, we don't even need to do Pythagoras theorem here, isn't it? All right, so all we got to do is find out this length, which is exactly at the midpoint. That means that is at this place. This length here is going to be x by 2. X is 12, so that's going to be 6. So you have 4.5 over there and 6 over here. That means that the let's find out this diagonal length. The diagonal length is again half of the entire diagonal length, which is 7.5 meters. So let's find out the area or the perimeter. Let's find out the perimeter is not asked anyway. Even if you want to calculate, that's just the sum of all the sides of the rectangle of the triangle, which is 4.5 plus 6 plus 4.5, that is 15. All right, so we can also calculate now the area of the triangle. Let's say, what is the triangle here? Let's DA. This is not DAE. Yes, okay. Area of the triangle DAE is 2 times, if I call that as F, 2 times the area of the triangle DEF. All right, so DEF, let me write that properly. Area of the triangle DEF. Okay, so this is going to be 2 times half into base. Base is then going to be 6. Height is going to be 4.5. So 2 and 2 goes away. 6 times 4.5. 6 times 4 is 24. 6 times 0.5 is 3. 24 plus 3 is going to be 27 meters square. Now let's find out the similar way, in the similar fashion, area of the triangle AEB. Area of the triangle AEB is going to be half of, if I call that as FG, this point if I call it as G, then it's going to be 2 times area of the triangle, what is that, AEG, and this is just going to be half times half times the base. Base of this triangle is 6 anyways, 6 because it's half of the entire x, which is 6, multiplied by the height. Height again is half of the entire height, which is 4.5. okay, so that is going to be 4.5. Right, okay, that is 2 times, isn't it? That's 2. 2. So you're then left with 27 meter square. Okay, so the area of this triangle here is also 27 meter square. Okay, so that is 27 meter square, 27 meter square, 27 meter square. So the problem is solved. I'll see you again in the next video.